Good to hear. It's been a great 2 days of the symposium, and here we are on the third day. This is really our crescendo. This is taking it to the finish. Thank you to everyone for making it in on an 8 o'clock start. I know that's an early start on the third day of 3 days of really informative, meaty topics. Sorry I couldn't be here yesterday. I had a family engagement that there are a couple things more important than drones in this conference, and one of them is my daughter's high school graduation, so I was there yesterday. I want to thank Ali Barami, Terry Bristol, Margaret Nagel, and Diana Cooper for yesterday's luncheon plenary session, from strangers to partners. It's always great to have senior leadership from FAA and industry give you their views of where we are in this industry and how we're moving forward. I also want to thank you for all the positive feedback we've gotten on all the panels. It's been really, I think, humbling for me to hear all that great feedback. I hope I didn't hit anyone with the laser. I meant to hit the clicker. Backwards. There we go. For a few reminders about today. First off, with the sessions, as long as the moderator shows up on time, we'll start on time. Also, please visit the Resource Center. I've been really happy to see every time I walk by the Resource Center, all the staff there are busy talking to people and helping people, and I think that's great. I was told that that is staged for when I walk by, but I've actually had other people walk by and confirm it is not staged. And thank you to all the folks at the Resource Center for their hard work. We also have a third day of how-to sessions, and so I hope you're attending those as well. Remember, our FAA staff are in blue polo shirts with the FAA logo above the right chest, and also the ones at the Resource Center say, "Ask me about drone safety." But anybody in a blue polo with an FAA logo should be able to help you with any of your questions. At the Resource Center today, our Before You Fly app partner, Kitty Hawk, will be out there. Remember, they're looking for beta testers for that new application. I meant to bring it on stage, but I didn't. Please take advantage of the Social Media Center down on the third floor, right about there. One of the things we're trying to capture is not just FAA people talking to the world, but we want to hear your story. And we want you to get your story out there, and I think the Social Media Center is very important for that. So please, take some time, go by, give them a smile, a quote, a picture, maybe a short video. Love to have you. We will use poll everywhere in some of the sessions and all the sessions here in the ballroom. If you were here for my third session on Monday, I apologize, the technology was not working well. You were sending questions in. I was not receiving them on the podium. So if anyone wonders why your important question wasn't answered, it's because the technology broke down, but we've since fixed that. We have a lot planned for you today. We have the keynote this morning. The panel is already seated. Thank you. We have tips on getting your 107 operational approvals. There's an opportunity to meet some of the steering committee from the UAS safety team. There's also an industry panel on doing business in the drone age. I'm hoping to stop by that one. I think that will be very exciting. We'll talk about risk management and how public agencies can get up and flying. We're very happy that we've had a strong turnout from public safety this year. And you'll see that we're having more and more activities, events, and sessions dedicated to the public safety community. And you'll even notice we've rebranded some of our I Love Drone Safety with a shield that resembles a public safety shield just for you. That's just this morning. At lunch, we'll have Bailey Edwards, the FAA's Assistant Administrator for Policy, International Affairs, and Environment, to lead a panel about delivery by drone and how we make these operations more routine. After lunch, we'll talk to state and local perspectives and talk about economic authority. And to close out, my colleague and our partner in this show, they really make this show hum and make it great. AUVSI, Brian Wynn and I will be up here to close it out. And I don't know exactly, but I predict some form of shenanigans will happen. Unlikely that we'll do things like put lobsters in each other's pockets or something like that. But we want to bring this whole event to a really nice close for you. So with that, I would like to introduce our first panel. Can we have the name slide up? There we go. So most of you, how many actually know PK's full name? Okay, so Parimal Kapardiker will be moderating the panel. So PK, with that, I turn it. Oh, and please silence your phones. That's just a friendly reminder. I'll turn this over to you.
All right, thank you. Thank you, Jay. We have a really exciting panel. So Jay, you and I have something in common. Our both daughters are graduated this year, and we are looking forward to paying the college tuition starting in August. So it's going to be an exciting time. All right, so we got a really exciting panel. Today I came in, I thought I was supposed to be here by 7:30, and by the time I looked at my watch, I didn't have a watch because yesterday someone liked my watch, so I gave away my watch, and which had the alarm clock on it. So few people called me and said, "Are you coming?" I said, "Yes, I'll be there in a few minutes." So it's sort of interesting that once you give away your watch and alarm clock, you have no idea what's going on. But that's the automation we're talking about here. So we have a really exciting panel today. Chris Anderson. How many of you haven't heard about Chris Anderson and the drone?
Nobody heard.
See, everybody's heard about Chris. Then Tom Prevost. Tom and I used to work together, and now he's director of aerospace at Uber. Chris, of course, started the whole drone movement, in my opinion, 3DR, and now the drone code, so it's really, really fascinating. You've seen his blogs and his posts and all kinds of stuff, and then, you know, he actually, it's a very interesting story Chris will tell you. I'll let him tell you how he started it and how he came about to that. And Tom and I were really close associates at NASA, and then now he's at Uber. We still continue to be close associates. He loves bourbon and beer, so if you want to hang out with him, that's the secret. Antonio is another awesome guy. He's been with Embraer for a long time, and they are pushing now not only the aircraft side, but also on the airspace side, so he'll talk a little bit about that. And I'm really super excited about Melissa, who is going to talk about the whole infrastructure needs and basically connectivity, what needs to have happen for drones and future automation. It's a really interesting and important topic. So with that, we're going to start with, let's start with Chris and say, give a few minutes of your wisdom here, Chris, and lessons learned.
Thank you. Let's bring up my deck. I think we have video, so I think I'll just stand up and do it here. If you could bring up my deck. Maybe I just press this. Well, while we're waiting to bring up my deck, thank you. There we go. As PK mentioned, I got this started with others about 10 years ago, and it was largely we didn't come from aviation. We came from software and robotics, and we just wanted to make robots fly, and didn't know how to fly ourselves. Just no piloting skills whatsoever, and wanted to keep it that way. And so, you know, my career has been focused on my arch enemy, which we call sticks, keeping fingers off sticks, and automation or autonomy has really been the theme of it. I think I press. I don't actually know if this works. Can we just advance to the next slide? This doesn't seem to be working.
Automation.
Yeah, can you automate my slides? Somebody, just advance. Back. Hello, AV guys. Oh, no, they're back here. Oh, I'm sorry. It's just not. There we go. Okay, let's go back. It's just not showing. Okay. I see. So my history is as follows. This is my grandfather. He was an inventor in Los Angeles in the 1930s. And what he invented was the automatic sprinkler system. Los Angeles at the time they were greening the desert. People were coming home after work, and they were turning on the sprinklers to water their lawns. And it occurred to him as a Swiss engineer that maybe the one thing that Swiss engineers always add is clocks to things. And if you could add a clock to a sprinkler, it could be an automatic sprinkler. He patented it, and it was released as the Rainmaster, which allowed you to go to the beach while your lawn watered itself. And I was inspired by that to not only, someday to start inventing myself, but also to not only invent something autonomous, something that ran itself, but also something that was incredibly boring and just worked. You put your sprinkler system into your lawn and you forget about it. Ideally, it just does its thing. And I always thought that drones should be as boring as sprinklers. They should just do their thing and get the job done and mindlessly just be there, present. In the same way that the electricity is present and the internet is present, it just should just work. So my entire career has been trying to get to that. Broadly, when we started, and even today, I don't mean to cast aspersions, but that thing on the left, that is the enemy, right? That thing on the left is obviously very important for a certain class of drones, but extremely intimidating to most people. It's complicated, it's expensive, it's got buttons. And furthermore, in our experience, almost all failures happen by people touching sticks. Human error is the biggest problem in our industry. And so what we do is we kind of reduce everything down to a red button. Someday we'll reduce it to no button, but as long as the FAA wants us to have a pilot in command, that pilot's going to have a red button. And that red button launches, and the red button can return, and that's pretty much it. If need be, there are some other elements as well. But that's essentially the way it works. And our customers are typically high school graduates. They're construction workers. They have a number of jobs to do. They walk into they unlock the gate at the construction site. They unlock the trailer. They turn on the generator, and they press the drone button. That's it. And they got a lot of other jobs to do, and they didn't set out to fall in love with flying robots. They're just trying to get their job done. And so that's the virtue of automation for us. And so what that does is it allows us to achieve economic efficiencies. Right now, drones as flying robots have really not got us anything in terms of efficiency. You still have one person assigned to one drone, and you should be paying attention for the duration of the flight. So they might as well be remotely controlled cameras at this point. They're not autonomous, or many of them are not autonomous. Now, what we do by letting the machine do the work is we start to move to the ratio. So the notion of teleoperation is now becoming very popular with cars. In Berkeley, where I live, lunches are delivered by these little Kiwi bots, these little robot cars, and they're everywhere. And you probably think of them fully autonomous. They're actually teleoperated from Colombia, the nation of Colombia, and they work great. They can basically make their own way down the street, but when it comes to a street corner, the teleoperator takes over. I think with self-driving cars, you're going to see the same thing, teleoperation, for the difficult parts. So there's a human present, but the expert may be available remotely. And there's been talk of even aircraft, manned aircraft, replacing one of the pilots with the ability to bring a second pilot in through teleoperation. And then ultimately, we're going to be doing massive fleets where you'll have thousands of these operated by a control center. And that's when we get these economies of scale. And so this is what it means in our business. A human surveyor for a construction site will cost about $1,000 a day. A drone survey right now with a human present, but not necessarily it's not two humans and they're not bringing the same equipment, will be about $100 a day. And what we're moving to is just a box on every site with a button on it. And the box does all the work, and basically the marginal cost of every additional survey falls to zero. And when we do that, they do more of it. And what we've been doing with what automation has brought us is not just the ability of drones to bring spatial resolution, higher resolution imagery, but we're also have the ability to bring temporal resolution. Not doing it once, not doing once a year, not doing once a month, but doing it every day, maybe doing it every hour. And the only way you can get temporal resolution and really get this digital twin, this true sense of what's going on in the world, is if it's done automatically at near zero marginal cost. That's the power of automation, and that is what we are working on. Thank you.
All right, thank you, Chris. So we will move to the next speaker, which is Dr. Tom Prevost, who is Director of Aerospace Engineering at Uber, and used to work at NASA for a while. So, Tom?
Well, good morning, everybody. Thank you, PK. I kind of want to start out with saying my daughter doesn't have a watch. Her watch is really kind of just her phone. And you probably have a phone too, and it does have an alarm function.
I muted.
for the next time. So Chris, I thought this was very fascinating. Great remarks. I'm going to kind of change this a little bit from, I know everybody here is probably primarily in the drone space, and I'm kind of looking forward to another one of those meetings in 1 or 2 years. It's called like the FAA UAS Symposium, where we're going to be talking about passenger carrying vehicles. And in order to transition us there a little bit, I'd like to show a video that maybe some of you have seen already, but it kind of gives you an impression of how we are thinking about the future of urban air transportation and passenger carrying vehicles, and what a journey like this might be, hopefully in a few years. So I'll see if we can get this video started. I don't know if I start it here or somebody else could do that. There it is. So our goal here is to bring electronic vertical takeoff and landing aircraft that are going to be built by our partners, like Antonio from Embraer here, into some of the most congested cities in the world. And we want to operate them at scale. Going back to Chris's point of making the economics work, it is actually only going to work that this is going to be an affordable option for anybody, just like in Uber X today, if we can operate those at scale. And the scale that we're talking about is something that, for example, will require us to use different approaches for airspace integration. So we are very much looking at a more something it's kind of UTM-inspired type of airspace integration, making a lot more use of digital communication and digital data connections. And we kind of really want to get ahead. I'm saying ahead, it's really not that far out. We're targeting demonstration flights in the next few years and initial commercial operations in Dallas, Los Angeles, and potentially one other city, international city, in about 2023. So this is really just around the corner. And there's obviously a lot of work that needs to be done, a lot of procedures, technologies that need to be developed. We are hoping, and one of the important features here that we think is going to allow us, especially for passenger carrying aircraft, to get into the market more quickly, is that we are going to start having pilots on board the vehicles, because we do need to prove out that the automation and autonomy is actually going to work. Of course, we do intend to operate these aircraft from the beginning very much like the way we would want to operate them in the long run, but we do have, again, we do have pilots on board that allow us to fly under VFR flight rules that can kind of manage the systems, and as we all know, I mean, there's always the kind of the expected, unexpected, the one thing that the programmers haven't thought about before, and there's going to be a fair amount of data that needs to be collected, where we need to work with the FAA. We're working with NASA on trying to kind of prove out that actually on potentially even just some routes initially, maybe you can, after a number of years, without any pilot intervention, you can start taking out the pilots potentially. And of course, all the learnings we're getting from the various drone activities that are happening today are very, very applicable to the passenger carrying vehicles as well. So we see a very natural progression, and are looking forward very much to trying to bring this kind of new kind of transportation to everybody. And if you live, I mean, people who live here in DC probably know about gridlock on the streets quite a bit and long commutes. I live in the Bay Area in San Jose. I work in San Francisco. Who's been in the Bay Area? That can be easily a 2-hour commute. I would love to just take one of these aircraft and hop over in 20 minutes. And I think I'm going to leave it with this right now and turn it over to Antonio.
All right. Who wants to fly to work? So, Antonio. So our next speaker, Antonio, who is Campolo, who is President and CEO of Embraer X.
Yeah. Okay. Good morning, everybody. It's a pleasure to be here. So Embraer is celebrating this year 50 years of anniversary, and we are leaders in the commercial aviation from 70 to 130 passengers worldwide. And we have the most delivered executive aircraft in the last 5 years, Phenom 300, and we are #1 in customer support in the executive aviation as well. So Embraer is a quite well-established company, and we decided to create Embraer X, which is the one that's participating in Uber Elevate initiative. We are one of the OEMs that are there. And we have announced 1 year ago the development of an eVTOL like this one, electric vertical takeoff and land, because we do believe that urban mobility is ripe to be disrupted. And you see the micro-mobility, you see everything that's already happening. So it's going to happen, something that it's in front of us. And the mission of Embraer X is to develop a new disruptive business. This is what we live for. And on top of Embraer footprint, it's a worldwide footprint. We have opened outposts in Silicon Valley and also in Boston to bring the best of innovation, the latest innovation, combining with our competence inside Embraer SA to make things happen. And from our research, we have found out that 300 million people worldwide, they commute more than 45 minutes in a very regular base within the urban areas. We have just had the Tom example, right? 2 hours in in the Bay Area. It's not uncommon. It's like in São Paulo as well, and many other cities around the world. So congested traffic is really an immense pain point. Nobody disputes that. I know that most of you have already experienced it, getting stuck in the traffic. And, it's about the quality of life of people. It's about the economic impact. Just to mention to you, New York metro area will have a negative impact in the economy of $100 billion in the next 5 years. So it's a very serious issue. It's a very important need of the community. It's not just a personal need, it's also an economic need. Then things are happening because there is this aspiration of people and entities and the whole community. One important thing that we need to mention is that this ecosystem, the combination of several initiatives, is happening now and is being built. It's not something that has the history, that has accumulated the history that we can base on. So if we look at the consulting companies today, Ernst & Young last year estimated a market of $1 trillion in 20 years. It's a huge market that's hidden there, waiting for somebody to bring the solution. And somebody should be somebody's, should be several companies at the same time doing that. It's not an easy task for a single company. Considering that this is a huge pain point, and this is a very important economic opportunity for everybody, is that we have decided to launch not only the eVTOL, but also aircraft services for the entire, let's say, fleet of aircraft, agnostic fleet of aircraft today. And we also have a company called ATEC, which is an Embraer company, that develops all the softwares for air traffic management in Brazil and some other countries. So we have the knowledge to go into the air traffic management. And when we think of that, we have launched last week a white paper about the path to 2030. And this white paper was made and was built in collaboration with ATEC that I have just mentioned, and Harris, that you all know. It's a very well-known American company, right? So, and our vision is that this is an incremental solution that's going to happen. If you look at near term, we are going to still have the segregation between air traffic management, UATM and UTM. UTM is a great initiative, and we do believe that is going in a very good direction. And it separates from and also complementary to air traffic management, and it's doing a very good job for drones. When we consider the entire market that is ahead of us for transporting passengers, what we are calling in this white paper urban air traffic management, because there is another layer there that will be populated by many and many aircraft. So, and ATM is everything, is a conjunction of many types of different aircraft and fleets that will be different aircraft in the same area, in the urban area. So this is a big challenge for all of us. It's not a big challenge for a segment. It's a challenge for the entire cities and the areas, urban areas. So we understand that we're going to move in near term from a very segregated layers, and we're going to move to in this very segregated layers to cross operation between or among the airspace there is just by exception. Then we're going to move for a more segmented airspace where we can cross airspace by authorization as well. And then long term, we're going to move to full automated area. So we understand that everything will progress using the new technologies, taking advantage of the new technologies, but it's going to be progressive. Unlikely the history that aviation has experienced up to now, we have a long history and lots of data. So there is an evolution of data that we have. Now we have to create the data. We have to experience. We have to have a use case. And this is what drones are doing, which is going to help a lot. You know? And suddenly, the eVTOL will come and will contribute to that. So data is very important, and the new technologies will be enablers. So ATM is one enabler to a big, huge market that's ahead of us. Just to conclude my presentation, it's not just about ATM. It's about the aircraft itself. It's happening. Most of new aircraft today are already being designed to be autonomous. And we do believe that is a progressive way. We need to have, in the UAS, will help a lot, and we need to have a use case in remote areas, and starting using for cargoes and so on. And if we have a structured operation, as Tom mentioned, starting with pilots yet, with one pilot, and then we're going to move progressively as we get data, as we test the edge case, you know, because the pilot has to be there to the unknowns that we have. So we still have to learn. We still have to progress till we get there. It's a very realistic point of view that we are bringing, you know, because we believe very much that the autonomous will be done. We're going to get there. But we're going to get there based on a very cautious way, because the passengers, they take for granted the safety inside aviation. And we are always working with safety coming first. You know? And couldn't be different in this case of new aircraft and the evolution of ATM. Safety comes first always. You know? And need to produce something that will gradually bring us to a level of safety and a level of experience that allows us to certify and to start operating autonomous flights. This is why we understand that for passengers transportation, we need to start with a pilot and evolve for a more autonomous flight. And we need to consider not only eVTOL, or not only the commercial traffic, or not only the UAS. We need to join force and need to work together to make a single airspace to be possible in the future. No, thank you for your time.
All right. Thank you, Antonio. Now, our next speaker is Melissa Tai, who's at Skyward, and she's going to offer her perspective on how the connectivity and the local regional items need to be considered as we start to look at drones and other emerging aircraft and automation that's going to support the whole ecosystem.
Sure. Thanks, PK. So it does say that I'm from Skyward, and that's not completely inaccurate, but Skyward is a Verizon-owned company, and most of my work is actually with Verizon. Verizon acquired Skyward about 2 years ago, and so that's where part of our interest in the drone industry lies. For those of you who might not be familiar with Skyward, it's a software company, and they produce software that is basically drone management. So if you own a fleet of drones, this helps you manage that fleet. They were also the first authorized LANC provider, authorized by the FAA. So there's a large mapping component to their software as well. So that's part of Verizon's interest in drones. And the other side that I want to spend a little bit of time talking about is our interest in connectivity. And so I'm assuming that most of you or all of you are very familiar with Verizon, probably a lot of customers out there. And so in the same way that we provide connectivity today to cell phones, tablets, and a myriad of other devices, we're also interested in providing connectivity to support drones. And what I want to do today to start things off is to show a video that shows some connectivity that we provided and how that might work. You know, right now, the phones that you're using, the tablets that you're using are primarily using 4G LTE, the 4th generation of wireless connectivity. Hopefully you've heard that we've just begun rolling out 5G, the 5th generation. And 5G is really going to be, we feel, transformational for not just drones, but for society at large. We like to call it the 4th industrial revolution because in particular we think it'll have a huge impact on business and the way business and manufacturing and supply chain, et cetera, is done. And so the clip that I want to show is actually from CES this past January. And in the clip, our CEO, Hans Vestberg, the CEO of Verizon, gave a keynote. And during the keynote, he introduced Mariah Scott, who's the president of Skyward. And Mariah came out, and together she and Hans launched a drone. While they were in Las Vegas, they launched a drone using a tablet. The drone was located in Los Angeles, and they did this over a 5G connection. So I just want to show that clip to show you a little bit about how we think that our connectivity can help support drones.
Necessary. And I bet we can get a glimpse of that 5G future right now. Hans, would you mind coming back out here for a minute?
I'm on my way. Hey, I'm back.
Let's conduct a test flight from right here in the auditorium. I have a remote pilot, a remote crew standing by in Los Angeles. And Hans, you have the controls to the aircraft right here on this iPad. Are you ready to fly the drone?
No, but yes.
All right, go ahead and press the launch button.
And where are we flying?
We are flying in Los Angeles. We're going to be testing 5G performance.
Perfect. I push there.
Push the launch button. Now, I should point out, we are actually flying an aircraft, but don't worry. I'm a licensed pilot. I can safely supervise Hans.
I'm supervised.
And make sure that he pressed the button. You can see our remote pilot in command, Tariq Rashid, is on the ground in Los Angeles. He's been testing 5G performance over the last month, and we are thrilled with the throughput that we are seeing. You can see the speed test. We're getting over 900 megabits per second. It's amazing throughput. Woo. Now,
that's good.
It's good.
Yeah. 5G ultra-wideband. Yeah.
Under current regulations, Tariq is in control of the operation, but you can see that he's not flying the drone. Using Skyward, we programmed the route that we wanted to fly, and Hans, you flew the drone.
Wow, I'm proud of myself.
When the drone finishes its flight plan, it will land itself.
Yeah.
Thanks for your help. Let me know the next time you want to fly. I'll set you up.
Great, Mariah. Thank you.
So that's just a glimpse of how we think that, you know, one of the ways that 5G can support drone operations, you know, that right there, just a little bit command and control. I think there's several other applications that connectivity will play an important role for drone operations, such as payload or UTM, et cetera. So we're really excited about 5G and the way that it can help, you know, kind of propel the drone industry forward. And looking forward to talking more about that today. Thanks.
Thank you, Melissa. Is Mariah in the audience? Let's see. If we have a CEO in the audience, I can't see her.
Yeah, I can't see anything.
All right, so let's start with some questions here. So there's a lot of discussion that goes on. This question is for everybody, but a lot of discussion that happens about pilot in the loop, pilot on the loop, role of human, role of automation. Lots of interesting dialogue, lots of researchers get excited and publish papers every year. So Chris, what do you think about, from your perspective and your sort of experience with 3D robotics and drone code and all the things you have been doing, what do you see the role of human and automation? What's the right balance here?
So technically, we don't, we've got millions of hours of automation. So we're pretty good at automation under certain, under certain conditions. The commercial use we do, farms or construction sites, et cetera, that's a relatively solved problem technically. We do have, for compliance reasons, we do have a human there. It's kind of boring job, as you can see. They just push a button and watch. And we'd like to build a safety case to allow them to go away. Maybe not go away entirely, but maybe be remote. So I think the stepwise progress is going to be that we'll build a safety case for remote operations. So right now it has to be unassisted visual line of sight. But of course the drone has better cameras on board and better situational awareness than I do on the ground with my old eyes and a dot in the distance. So I think step one is technologically assisted line of sight. Step two is remote operations. Step three is remote operations of fleets rather than just individual ones. And I think that basically we have the technology in place to do it right now. The 5G networks are the perfect platform for remote operation. We're doing it on the ground. I think we could do it in the air as long as we constrain the space and have a kind of a regulatory path that allows us to acquire data and build confidence. That's the way it's going to go.
All right. Tom, same question for you. What do you think from the perspective of urban air mobility and the drone work that you guys have been doing at Uber? What do you think is the right balance of role of humans in automation?
Well, I mean, we do think that essentially the orchestration of the entire fleet operations are certainly much better done by automated systems, optimization across multiple modes. When you think about you want to go from A to B, you don't want to go from one skyport to the next. You want to go from your house to wherever your work or something. So there's a much larger orchestration that potentially gets you a car, a scooter, or a bike initially to your first leg, and then maybe connects you into public transportation in the end. When you think about the complexities of arranging all these different trips, I do think that's for potentially thousands or tens of thousands of people, that's far beyond the capabilities of a single human to plan in a sense. So I do think there's certainly automated systems. Now when it comes to oversight, we got to make sure that we put the right roles for the humans in there. I mean, even safety pilots on board the aircraft, like you're talking about, the role cannot be, we don't give you any information and then we throw you into a situation that you can't handle. So if we have humans in the system, we got to make sure that their job is designed properly and accordingly, that they actually add value, have the right information to make informed decision in cases things come up. So I do think there's this kind of a tricky balance in there, but at the same time we also know that very often this transition from automated operations to human operations is where most of the difficulties and touch points are coming from. So I do believe this is let's say something that will require a lot of thought. But I think it's very well possible to fly the vehicles in a much more automated fashion. And in a sense, if you utilize structure, if you utilize procedures, we're already flying aircraft highly automated, and you have good contingency procedures, I think there's definitely a pathway of getting there over time if we can just collect the right amount of information. But along the way, as long as we do have humans in the system, we also got to make sure that they kind of have a reasonable job and a reasonable working environment.
Can I follow up on that one? I mean, because I think this this question of how do you keep the pilots engaged and aware of the surroundings when they really have almost nothing to do? What is their value add? And this is of course going to be true on the ground as well as Uber autonomous cars. So what will the quote unquote pilots do when the main flight function is entirely automated?
I mean, if you ask me, I think one of the primary functions initially is going to be also traffic awareness, kind of making sure sort of the see and avoid function. We even today, we don't have really sophisticated detect and avoid technologies for beyond line of sight, which I think we're getting there, but hopefully we're getting there pretty soon. But I think that's an important area where we need to make sure, also kind of managing the systems, making sure everything's kind of working properly. I don't see it as much as like manual flying or anything. I mean, these are all going to be fly-by-wire aircraft that are hopefully going to be very simple to actually operate themselves.
Antonio, from your perspective, I mean, you guys are involved, Embraer is involved in both sides,
Yeah.
aircraft as well as the air traffic management. What do you see the role of automation and the balance of human and automation, or should there be any balance? What do you think about it?
Yeah, so I think it's a very important point because humans are everywhere, right? Controlling everything, including the pilots and the guy that's in the control tower and the guy that's operating the software and so on. And there is a very important role of the humans today. For instance, in the aircraft, the pilot is part of the safety equation of the aircraft. You cannot just remove the pilot and it's okay. So you need to design to be autonomous. So the new aircraft now, like our eVTOL, are being designed to be autonomous ready, right? Of course, to get the experience, to understand everything that may happen, it was not predicted before. We need to have experience, we need to have many things. This is why we need pilots operating the aircraft as time goes by. So one important point is that automation will relieve the human workload progressively. If you get, for instance, in the air traffic management, you can dynamically control the routes. If you are flying over a city and you find bad weather, let's say, then you may indicate automatically which is the route that you need to get. But this requires lots of big data, requires artificial intelligence, requires another way of doing things because the number of aircraft flying is cannot be handled by humans as they are today. So we need to, for instance, we need to move the air traffic controller to a supervisor rather than somebody who controls each flight, right? So this is an example. And the pilots itself, they will evolve and the workload will reduce a lot. So as we come to a point where we can make everything autonomous. But we know that autonomous will leverage everything because we'll improve the safety, we'll bring a much more meaningful business plan for everybody. So it's a very powerful and important approach that we need to all have. But to get there are lots of things to do and to be learned, mainly when we talk about transporting people.
So Melissa, can you talk a little bit about what Verizon is doing to enable the role of automation and enhancing automation for better efficiency for aviation and other applications, but primarily aviation?
Sure. So, I mean, primarily what we're doing is building and expanding our networks, both with building 5G, and we were the first in the world to launch just this year, and we've announced 5 cities, and we're going to expand to several more by the end of this year. So I think that's our primary focus is building out the 5G network. And just to give some context into what that means for automation and for drones or any vehicle, if a vehicle is traveling at 60 miles per hour and it's using 4G LTE connectivity, it takes 4.4 feet to stop when it receives information that it needs to stop. That's the distance that it travels. On 5G, it stops in 1 inch. So that's a significant difference. And especially when you're talking about urban air mobility or autonomous vehicles, if you're a pedestrian on the sidewalk or somebody in the neighborhood and this urban air mobility vehicle is landing, that's a big difference and that's important. But I think the other thing that we need to think about when we talk about the role of humans isn't just the fact that the technology is, makes it safer, but also how do we get people comfortable with that? Because we can show tests upon tests about how this technology is safer, but we all know that it's just one or two incidents where the technology fails, and it has an outsized impact. It can undo all that data that we have. We can say, we've traveled millions of miles and this is safer than human drivers or human operators, but just one or two incidents and it undoes everything. And if you look at the polls and the data collected on Americans that are willing to ride in an autonomous vehicle or put a loved one in an autonomous vehicle, it's much lower than, frankly, it should be rationally. Like people should be more willing to do this, but they're not. And so I think that's one of the big challenges, is getting people comfortable with this. And we can talk all we want about how this is safer and proving it, but I think that's something that we need to think about, and we need to do that work kind of outside of rooms like this and conversations like this, and reach out to the communities and to the public and talk to them, and listen to them, and see kind of what they need to feel safe with this technology and to adopt the technology.
Great. We'll take a few questions from audience. This is starting at 9:20, so we got time.
You have to go to break, PK.
All right. One question?
One question.
One question from the audience. Anybody? Age of automation. I'm sure you're excited about it. Come to the mic.
Talking to my chest.
All right. Okay, look, buddy. All right. So if your dream for the Uber comes true, if we walk with you into the future, and in a city that has 50,000 commuters a day, I have two questions. One is, what percentage of that 50,000 commuters do you see riding an airborne Uber? And then the next question is, how can that possibly work with 50,000 vehicles in the air?
I'm not sure if I understood the question. Did you?
No, he's saying that what percentage of people will be riding through air, and what percentage will be riding through on the surface.
And if you're going along to that many, how do you keep
Yeah.
everybody? How do you not create the same problem in the air that you currently have on the ground right now, I guess?
So I may talk a little bit if I understood well the question. I don't think that the air mobility will solve all the problems of ground mobility. No, it's not the case. We're not doing that considering that we're going to solve the congestions in the big cities because this requires lots of actions in many areas. But we do believe that we will make a flight for thousands or even millions of people much easier, much more accessible than it is today. Then many more people can enjoy the flight and coming to where he wants or she wants in a shorter time, because we want to give people the right to decide what they do with their time. If they want to stay 2 hours in a traffic jam, or if they want to keep 15, 20 minutes to get where they want, of course there is a difference in time and price, for sure, but it's a choice. We are allowing a choice, and we are allowing more people fly over the cities in a very safe way. It's gonna, like today, aviation is even safer than driving. No? So, and this is what we see, how we see the future, people choosing where they want to go, and that this doesn't necessarily solve all the traffic jam that we have on the ground.
All right, Mr. Uber, you want to quickly answer that question?
Well, there's no real quick answer to that question, I think. But the one thing that I do want to point out is when you think about that in big cities today, we have at any given time sometimes millions of cars on very narrow two-dimensional roads. Why is it so? Does it seem so unthinkable to put tens of thousands of aircraft in the three-dimensional airspace above it, if we can develop a structure that allows this and a concept to manage it. I mean, I kind of just want to leave it at that.
Last word, Marlisa?
I mean, we're just really excited about the potential for this. I think we really need to think about how this is going to scale, because without scale, I don't think the industry is able to move forward. Appreciate the work of the FAA and what they're doing to move forward. Very, very excited to see some remote ID rules come out, and you know, looking forward to working with the FAA and other regulators going forward.
All right. Thank you, all the panelists. And Jay, back to you.
Thank you. Please, a warm round of applause for our panel. Thank you, Melissa, Tony, Tom, Chris, PK.